Ladies and germs, round 3, we are talking about hyperbolas. Hyperbolas are shapes that are created when you cut that conic section vertically and it hits one side making a parabola here, another side making a parabola. It's kind of hard to show with my hands like this. But one way to think about it is we've got our ellipse, our normal ellipse like this, right? And the focus are in the middle. If you were to like push your hands together, and then you would have these two parabolas like this, but your ellipses would be inside each of the parabola. Sorry, your focus would be inside each of the parabola. That's what I meant to say. So the focus is still inside of our graph here. It is inside each parabola. We've got two double parabolas. Looking at our equation, I hope you recognize that this stuff is very similar. The center is still H and K, ladies and gentlemen, still centered H and K. This time, though, the orientation for horizontal and vertical comes upon the sign. So notice this right here, all right? Notice this right here. We've got positive x squared. That's what makes it horizontal. We've got positive y squared. That's what makes it vertical. The size of the numbers on the bottom does not matter. It is all about which variable is positive. So be very careful. If you see a subtraction, it's got to be a hyperbola, okay? All right, this C right here is still our distance to our foci, so that's nice. To find the foci, we're still going to be adding to the x value and the y value to find our foci. But now we've got these asymptotes, all right? The parabolas follow these lines, and these asymptotes, ladies and gentlemen, are based upon A and B right here. And in this case, it's going to be the y value over the x value. And here, it's the y value over the x. So this is nice to know. The slope is always y over x, just like it used to be. Rise over run, so y over x. Even though those are switched, it's because they're switched in our equation up here. So it's our vertical value over our horizontal for both of these, all right? It's the vertical over the horizontal. And the slope's important because they're always going to go through the center, and you just get to count the rise over run. This picture does a really good job of showing it. Here's our center. There's our vertical distance, B. It's always going to be the value under y. Here's our horizontal distance, A. It's always going to be the value under x. And our slope will always be up B over A. So always vertical over horizontal. All right? Now, because the definition where the is a little bit different of our foci, it's actually the difference of these two sums. On the ellipse, we would have added those two together and it would have been a perfect oval shape. But here, it's the difference. This is an important thing to notice. We still use c squared equals a squared and b squared, but this time it is addition, all right? It is addition. Very, very important that you make sure. So an ellipse has a positive inside our equation, but a minus in the c equation. A hyperbola has a minus in the standard form, but a plus in our c standard form. All right. Yeah, so we've got this transverse axis and conjugate axis, but what we really focus on for hyperbolas is our asymptotes. And we'll do some examples. So we've got this picture here. Orientation is vertical. Why do I know? Because y is positive. It's vertical because y is positive. Okay, our center, we should be able to recognize that it is, I'm going to zoom in. Nope, wait for it. There we go, that's a little bit better. -2, comma, +1. So here, watch what I'm going to do. I'm going to go ahead and graph most of this. -2, +1, there's our center. The number under y is still how we move in the y-axis. So I'm still going to go up 4, because it's the square root of that number. 1, 2, 3, 4. And I'm going to go down 4. 1, 2, 3, 4. The horizontal distance is 9, which you take the square root and get 3. So I'm going to move 1, 2, 3, 1, 2, 3. Now, here's a big mistake. A lot of people want to put a circle around that. No, no, no. This is a hyperbola. Use a dotted lined box, and you'll see why here in a minute. Okay? Use a dotted line box. Our vertices are the edges of, the points of the parabolas. Because it's vertical, I know my parabolas are going to go like this, making these my vertices. So my vertice is -2, comma, 1, 2, 3, 4, 5, and -2, comma, 1, 2, 3, -3. Okay? And here are my asymptotes. They cut through this like a knife. So technically my parabolas should be a little bit wider following those dotted lines, but this sketch is just fine. So the slope of our asymptotes, I'll come back to foci in a minute. The slope of our asymptote is the rise and run of this box right here. It is our y value 4 over the x value 3. So the slope is 4 over 3. But be careful. It says slope. It should say slopes because there's two slopes. It is a positive 4 over 3 and a negative 4 over 3. Don't miss that. Okay. Now this allows us to find the actual equations of our asymptotes. Alright? We know it's going to go through the center, this coordinate point, and we know it has this slope. So what we can do is use point-slope form. I'm going to bring it up here because it takes a little bit of work. Asymptotes. But what we can do is we can use point-slope form way back from Algebra 1. Y minus y1 equals m times x minus x1. Because y1 and x1 is the point that it goes through, that's our center. And m is our slope 4/3. Y minus 1 from my center equals 4/3 times x minus -2. So I'm going to change that to a positive 2. And then we just distribute our 4/3, and we get 4/3 x. 4/3 times 2 is 8/3. Add 1 on both sides, but I'm not going to add 1. I'm going to add 3/3 because that's the same as 1. And I get y equals 4/3 x plus 11/3. And that's our first asymptote. That's this dotted line right here, because it's a positive slope. Now you can't just change the sign of the slope to find our other asymptote. We have to do that whole thing again, except this time we're going to use -4/3. Y minus 1 equals -4/3 times x plus 2, because it's going to be the same right there. But this time when we distribute, we get -4/3 x minus 8/3. And when I add 3/3 this time, I get y equals -4/3 x minus 5/3. So those are the two equations of my asymptotes. The slope is going to be super important, ladies and gentlemen, because that defines the a and b values. So if they give us the slopes, we're going to use that. I'll show you here in a minute. All right, the foci. We need to use c squared equals a squared plus b squared. I have run out of space on my paper, so I'm going to magic. Here we go. To find the foci, c squared equals a squared plus b squared. All right. Now, because we have an addition sign, you can mix these up. It doesn't matter. C squared equals 4 squared plus 3 squared. If I put those backwards because I went the other way, it wouldn't matter. I'd get the same exact value. C squared equals 16 plus 9. C squared equals 25. Square root of that is 5. That, ladies and gentlemen, is the distance to my foci, remember? So from here we go up 1, 2, 3, 4, 5, because we know the foci lies inside the parabola. And from here we go down 1, 2, 3, 4, 5. There's our two foci. And really what we're doing is just adding 5 to the y value. The negative 2 stays the same. 1 plus 5 is 6. That takes us up to that point. Negative 2 stays the same. 1 minus 5 is negative 4. It takes us down to that point. Alright, and there we have all the important information for asymptotes based upon standard form. Number 3, they don't give us standard form, so we're going to have to do all that work. We'll do that in a minute. Let's talk about this one. Write an equation for the hyperbola with the given characteristics. Let's first graph the points given. 3, 0, beautiful, and 9, 0, beautiful. What's very important to understand is they tell us these are vertices. That tells us the orientation is horizontal because they're on a horizontal line, right? I know it's going to go like this. Boom. If they tell me my vertices of a parabola are these two numbers, we can graph it. Sorry, hyperbola. We can graph it, but we don't have all the good information. So let's keep going. But I do know that I can find my center by going halfway between these. 1, 2, 3, 1, 2, 3. So there's my center at 6, 0. So I know it's x minus 6 squared minus, and I know it's x first because it's horizontal, y minus 0 squared equals 1. Yeah? See, we know all this information. And this value here, 1, 2, 3, is the value that goes under x, 3 squared, right? Now all I have to do is use this equation here. This is my slope, and these are my asymptotes. So watch what happens when I graph these. Negative 12, up 2 over 1, 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 up 2 over 1. Wow, it crossed through my center. That's what asymptotes do in this example. So dot, 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 dot. Positive 12, down 2, back 1. Almost done. Boink. There's my other example, alright? So here's the trick though, because if I know that this number is 3, we have to figure out how high does this go, right? This is my box. And so if we think about this slope as 1, 2, 3, 4, 5, 6 over 1, 2, 3, so 6 over 3, that's where the 3 comes from right here. But what's 6 over 3? It's the same as 2. Alright? It's the same as 2. So I know that this value is 6 squared because it's always the vertical distance here. Simplifying, x minus 6 squared over 9 minus y squared over 36 equals 1. Bingo. Please rewind and watch that again if you got lost. Okay, here comes the super duper fun part. Completing the square. If you have not gotten good at completing the square, don't worry, we got another review day coming up for practice, but you had better be practicing and coming to tutorials if you need help. Here we go. 25x squared plus 100x. I'm grouping my x's and y's. Minus 16y squared plus 96y equals 444. I already know it's going to be horizontal because my x squared is positive. Factor that out. Gives me x squared plus 4x plus 0. Oops, sorry. I meant plus blank. Minus 16 y squared plus, gonna use a calculator because I'm not sure what 96 divided by 16 is. Oh yeah, it's 6. I knew that. Just kidding, I didn't. Equals 444. Because I'm now on this side, I'm going to add 25 space. Now watch this. I'm actually subtracting this 16 times the space from here because it's a negative 16. Negative 16 times that space. Be very careful with that, alright? This is 25 times the space plus on this side, plus 25 space. Minus 16 times the space, minus 16 times the space because it's on both sides, alright? Now we just do b divided by 2 squared. Oops. So we write 4 divided by 2 squared is 2 squared, which is 1. Just kidding, 4. That goes here and there, which leaves me with 25 times x plus 2 squared. This bad boy, I'm just going to go ahead and drop down my minus 16. 6 divided by 2 squared is 3. Squared is 9. 9. 9. Okay, so this becomes y plus 3 from that number, squared, equals whatever all that junk is. I'm going to use my calculator. 444 plus 25 times 4, which is 100, minus 16 times 9, which is something. 400. Awesome. But our standard form of hyperbolas and ellipses equal 1, so we divide by that 400. We divide this by 400. And then we just simplify. 400 divided by 25 gives us 16. So the denominator here is x plus 2 squared over 16 minus, get this, 400 divided by 16, that's right, it's 25. So y plus 3 squared over 25 equals 1. Whew, okay. Our center is negative 2, negative 3 from that bad boy. Negative 2, negative 3. Okay. And then we're going to go left and right 4, because I take the square root of 16. 1, 2, 3, 4. 1, 2, 3, 4. We're going to go square root of 25 and go up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we make our magic box. I'm going to go ahead and draw in my asymptotes this time so that I can make my parabola as perfect as possible. I know it's horizontal because x is positive, and they got to follow those wide bad boys. Boom. Follow those wide bad boys. Just like that. Gorgeous. Okay, the slope of our asymptote is always the y change over the x. 1, 2, 3, 4, 5 over 1, 2, 3, 4. Notice 5 over 4, y over x. Plus or minus 5 over 4 because there's 2 of them. And then our asymptotes, did we get lucky here and get whole number y-intercepts? Probably not, because if we did, it would have crossed on that whole number. So I'm going to tell you to go back and do that work for your asymptotes, but I'm not going to actually do it. Check the key to make sure you did it right. But our foci are important, so I'm going to use this space for that. C squared is what I'm looking for, equals a squared, doesn't matter. 4 squared plus b squared doesn't matter, 5 squared. So c squared equals 16 plus 25, and that magic number is 41, which is not a perfect square, so we can just take the square root. But we do remember that because it's horizontal, we're going to add that to our center on the x value. Okay, we're going to add that to our center on the x value. So here we go negative 2 plus the square root of 41, just for estimation's sake. Square root of 41 is 6.4. So 1, 2, 3, 4, 5, 6.4 is about right there. 1, 2, 3, 4, 5, 6.4 is about right there. But the good news is we can write these as negative 2 plus the square root of 41, comma, negative 3, and negative 2 minus the square root of 41, comma, negative 3. Ta-da! That got really messy, and I am sorry. Please rewind, slow it down, come see us in tutorials, more importantly, and have a great day. Less than 20 minutes. Boom, yeah.